Good afternoon and welcome to our new webinar series. We are now presenting to you very interesting topic. And before this start of the webinar, I would like to thank all of the admin guys who are working behind the scenes day and night to make these webinars successful. And without their efforts, without their continuous contribution, these webinars would not be very successful. And we should be very thankful to all of the team, and so that they are encouraged more to participate and do their best efforts to make all this webinar successful. So right now we have with us the community gentleman, and today's our topic will be regarding the UAE building codes for MEP engineers and how to build the compliance, which is being presented by Engineer Murtaza. Engineer Murtaza has got an extensive experience of designing from all the MEP codes, building codes of the UAE with various. He has worked with various authorities and has got a lot of experience on how to deal with the local codes and standards as well as the international standards. So he is well versed with all the authority codes of all the seven Emirates, including Abu Dhabi, Dubai, and Sharjah. And we should take maximum experience, expertise of it to ensure that we are uh, getting all the information and through this webinar. At the end of the webinar series, there will be a Q&A session as well. Uh, Team members can note down the questions and we will be ready to answer the questions. Murtaza, please go ahead with your presentation. Thank you.
Thank you, Engineer Abdulajit. I hope I am audible to everyone and the screen is visible now.
Yes, yes.
Good afternoon, everyone. Thank you for joining for today's session. I see most of them would have taken out their time either from their families or from their office time, and then they are coming in and joining on the webinar today. I hope the webinar is going to be something which you will take from today's session, and there will be a lot of things which I'll try to share based on my experiences, based on the authorities on with which whom I have worked, and some of the case studies and some of the key compliance requirements what we need to follow as MEP engineers. The whole idea regarding today's webinar would be mainly to understand what are some of the basic mandatory requirements for the different authorities. The second thing is what are some
Engineer Murtaza, you are in mute.
sorry, am I audible now?
Yes, yes. Yeah, yeah, you can go.
Thank you. Thank you. Good afternoon, everyone. Thank you for joining for today's session. I know most of them are taking out their time and joining today's session related to the building codes. I'll try to keep it very comprehensive and ensure that I share maximum information and knowledge which I have accomplished in terms of working as a consultant over the past few years here in UAE. In today's session, mainly we'll be studying or taking you through to three important aspects. One is the mandatory requirements for the building codes. The second thing would be the authority watch points. What are the important things we should be very careful about when we are doing the design? And third thing would be some of the case studies which I would be sharing with you. So moving forward, in today's session, the objective mainly would be to understand the hierarchy of the UAE codes. I'll take you through the approval process, how generally the consultants are getting the approvals in terms of getting their building permit. We'll be going through some of the key MEP services related to HVAC, electrical, firefighting, as well as plumbing and water supply in regards to the regulations and the requirements of the authorities. Also, we'll be decoding the approval work process and why does the approval get rejected most of the times. What are the key aspects that we need to concentrate as MEP engineers and ensure that the drawings, whatever we are submitting, are getting approved. And some of the best practices and case studies which I have worked on. And hopefully at the end of the Q&A session, I would also like to hear from you what are the challenges you have faced when you have submitted the drawings and what are the some of the comments which you are receiving from the authorities. So all of us can have, a knowledge exchange in terms of the comments and the rejections what we are receiving from the authorities. Moving forward, just to take you through the different codes which are there here in UAE. I know most of the some of the people have also joined from other countries. We have few people joining from India, and some of them are joining from other countries. So I just wanted to ensure that everyone knows what exactly are the different codes and the regulatory framework in which we work here in UAE. So we have Dubai Municipality, we have Abu Dhabi Municipality, you have UAE Fire and Life Safety Civil Defense Code, which comes under the Ministry of Interior. Then we have DIVA, which is for the Dubai. And then we have ADIVA for Abu Dhabi. We have SIVA for Sharjah. And then we have FIVA, which is now called Etihad Water and Electricity, which is for the Northern Emirates. Apart from this, also, we have few specific different free zone authorities. So when we go into the free zones, there are certain specific requirements which we need to comply with in terms of design. So there are different entities like we have DDA, Dubai Development Authority, then you have Tarafis, similarly you have Javza, and similarly you have Dubai South. The overall standards remain the same, but the process of getting the approval and the documentation which is needed is something which is different for different authorities. I'll be taking you through some of the free zone authorities as well, and what are the specific things which are being requested by the free zone authorities. The code hierarchy in UAE projects. So basically as an MEP engineer, the first thing what we do is in terms of getting the approval is start with the architectural design and ensure that we as MEP engineers starts to give them the minimum approved requirements which are needed for all the different authorities. We will take an example, of a G plus 50 building throughout the entire presentation, and we will try to see how the different codes are being applied for a building which needs to get authority approval. So generally, when we start with the project, the first thing what we do as a design engineer is try to ensure that we are doing proper zoning and ensure that we are trying to meet the minimum requirements which are being specified by the authorities. Let us take the example of UAE Civil Defense Authority. So one of the most important aspects when we start a project, what we need to look at the design stage with the architecture is whether the building is complying for fire life safety. We have to prepare the fire life safety design plans. So we need to ensure at the initial stage itself whether there is compliance which is being achieved in terms of travel distances within the building. Apart from that, you need to check whether the breaching inlet is complying with the requirement, whether it is available near towards the road access, whether the staircase widths are complying. These are all the things which we work as an MEP engineer with the architect. Also, you need to comply the distances between the staircase, whether it is complying as per the UAE fire code. Along with that, also we need to ensure that whether the building is complying in terms of corridor width. So these are some of the examples with which we initially start the design phase with the fire and life safety code. Before even we start the design of MEP services, there are architectural aspects which should be considered as a design engineer. Apart from this, also we need to ensure and we need to um, comply with the requirements of openings. So generally you are planning for OTS. So if we take the example of Sharjah, so there is a specific requirement that for gas risers, there need to be a dedicated opening which should be provided. So this also should be incorporated at the initial stage of the design. Similarly, when we go for Dubai, you have fresh air handling units. So there are minimum requirements which are needed. So when proper planning is being done at the initial stage of the design, we ensure that the complete design comes as a whole package at the initial stage itself. And then later on, when we go on to our technical design, let it be related to DIVA requirements, or we are going to go with SIVA requirements, the compliance becomes much more easier. So one of the important aspects what we need to understand is the life safety report. work in collaboration and in coordination with the architect engineers, ensure that all the minimum requirements are being met at the initial stage. Moving forward, utility manuals. So there are already technical guidelines which are available. So we have the DIVA guideline for water, you have the DIVA guideline for electrical installations. Similarly, for Abu Dhabi, we have the same. SIVA we have, and also for FIVA. Moving down on the presentation, I'll show you all of these guidelines and how we are utilizing them. Along with this, also there are local authority regulations, like we have Dubai municipality, we have Sharjah municipality, similarly we have Abu Dhabi municipality. So these are the municipalities which are generally looking at different drawings related to drainage. Not only that, they are also ensuring that there are structural and architectural drawings are also being complied. So this is another aspect of the approval process which we need to look at as MEP engineers. All the different codes what we see now are from the parent codes, which are the international codes, which are coming from ASHRAE. You have NFPA, you have International Electric Code, you have BS standards. So these are the parent codes which are being adopted here locally in UAE, and then you have your local codes which are being developed, and then there are certain modifications which are done in these code related to our region and our in order to comply with our local requirements. It can be climatic conditions, it can be conditions related to uh, extreme conditions which are not generally available in other countries. So based on that, the codes are generally modified and then they are formed for our local requirements. So this is the basic hierarchy of the UAE projects. I just wanted to take you through. Moving forward, just wanted to show you the typical workflow process on how do we get the building permits here in UAE. So initially there is a concept design which is being prepared with the architects and the structural team. We as MEP engineers prepare the concept design, ensure that all the design is being compliance with the minimum requirement of the authorities. Then we go on with the detailed design related to the drawings, calculations. Detailed design in the sense it's more related to the calculations, because when we submit to authorities, a lot of calculations will be requested. So we need to ensure that all these details are prepared during the initial stage itself. And then parallelly specifications. The reason why I'm mentioning calculations and specifications here and the detailed design is to ensure that our design is meeting these requirements. The things which we are going to specify, we need to ensure that these things are already mentioned on the drawings. So later on, there is no conflict and no RFIs are raised. There is no lot of confusion which is existing once the drawings are tendered out. So we need to ensure that during the initial design stage itself, that all the drawings are complying with the requirements what we are going to be tendering out later. So the first step, once all the drawings have been prepared, would be to get the civil defense approval. So once we prepare the architectural drawings and the civil defense drawings, it can involve a lot of drawings in the civil defense. So it can be life safety, LSR, then you have your firefighting systems. Along with that, you will be having your if your if your project is in Dubai, so you will be working on LPG. If you're going to submit for civil defense, if it is super high rise building, in that case you need to prepare smoke management system depending on the building classification. And also you have fire alarm and emergency and voice evacuation as well. So all these drawings are generally prepared at the initial stage, that is the at the civil defense approval stage, and then submitted to the civil defense authorities along with the architectural drawings. So this is the first stage of approval, which happens in terms of getting the building permit. Once you have the civil defense approval, later on we move on to get the other authority approvals. Again, it depends on different, jurisdiction of authority. If you're working in Dubai, the process will be a little bit different. And when you're working on Sharjah, the process will be different. However, the ultimate goal is to get the authority approval related to water, electricity, gas in terms of Sharjah, whereas in Dubai, you already got it in terms of the LPG through civil defense. And then you have the drainage approval. These are some of the utility approvals which needs to be, which we need to get in order to get the building permit. Apart from this, we have Etisalat as well. So that is also something which you need to get an approval for. So as a design engineer, these are some of the things which we need to get approval before even you start any construction on site or before even anything can happen on the site. So this is the process which we generally follow in terms of getting the authority approval. And once all the drawings are approved by all the different authorities, that is when we get our construction NOC or the final NOC. So once the final NOC has been received, then we move on to the next stage of construction. So till now, what we saw in terms of the approval process was just to get the construction NOC or the building permit for us to move ahead in terms of construction on the site. Moving forward, what are some of the top reasons for us to get the rejections from the authorities? I have just listed down a few specific things in general related to all the authorities what we have here in UAE. The first and the foremost thing is that the drawings are not matching the calculations. It can be anything related to any authority. Generally, whatever we are showing in terms of the calculations, the same is not reflected on the drawings. So, for example, if you take a civil defense drawing, you are showing the staircase pressurization calculation, and the flow which is being mentioned for every floor in the staircase might be different, and then on the drawings it is something which is different, which is not matching. So this is one thing which can directly get you a rejection. Similarly, in HVAC, if the calculations of heat load calculations are not matching on the load schedule, again you have the rejection. Again, you have the fresh air calculations. If it is not matching your calculated values as what you are showing on the drawing, again, there is a rejection which can happen. And then again, the process is that you will have multiple submissions which you need to be doing. I think someone is raising their hand for questions. We can have the Q&A. You can list down all the questions. I'll try to answer all the questions at the end. Moving forward, some of the other reasons for rejection in terms of civil defense is non-compliance of fire strategy. Generally now civil defense is looking at how you are going to be submitting the staircase pressurization. Then the control sequence for the pressurization also needs to be mentioned. So this is something which we generally need to ensure that we are having the compliance with, and which is being shown on the drawings. Another important thing is incorrect authority forms. So generally when you are submitting the electrical loads, so the loads which are mentioned on the drawings are not matching on the form. So for example, the electrical load for my project is, let's say, around 300 kilowatt. Whereas on the authority form, you're mentioning it on 280, or the unit itself is different. Instead of kilowatt, it is kVA. So these are some of the things which generally cause you to get the rejections at the initial stage of submissions itself. Similarly, when you have poor discipline coordination, when you are going to submit, let's say, for example, you are submitting a project where you have structural elements as well as elements related to drainage and plumbing. So generally in Sharjah, the authority reviews drainage drawings as well as the structural drawings. So in that case, when there is no proper coordination between the structural elements as well as the plumbing elements, there can be a rejection. An example for that would be if your water tank is less than 1.5 meter away from a soil line. Then in that case, the authority can give you a comment, and they can mention that you are not complying with the code, and then you have a rejection. And again, you need to go back and check how you can reroute your drainage piping. And again, you need to check how you can move or you can modify your structural element, that is your water tank. So this is also something which needs to be looked at the initial stage in terms of having a proper coordination. So poor coordination is also one of the reasons why you have multiple rejections from the authorities. Moving forward, I'll be taking you through now some of the mandatory code requirements what we generally have. So we will be going through different building services. So the first one what we have is HVAC. So some of the mandatory requirements which we need to comply in terms of getting the authority approval are ASHRAE standard 55, 62.1, 90.1, and also you have the UAE fire code in which you need to comply for the smoke control. So these are some of the mandatory code requirements which we need to ensure that as MEP engineers we are complying in our design. Some of the mandatory requirements what we need to be submitting to authorities. So if you take the example of the same project which I was discussing about G+50, when we are going to submit the project, let's say to DDA authority, Dubai Development Authority. So these are some of the important aspects they are going to look at. So the first thing is whether you have done the heat load calculation. If you have done the heat load calculation, are you attaching the HAP archive file, .e3f file? Are you giving them the U value calculations? for the roof, for the wall, for the window. So there are specific U value calculations which needs to be done. Even if it is a villa in Dubai, you need to do the U value calculation. Similarly, now in Sharjah also they are requesting the U value calculation is generally submitted with the electrical drawings. Apart from that, you also need to do the condensate calculation. So just a quick question to all of you. You can answer the question at the end of the session. So what is, you can just let check, or you can tell me what is the minimum, load which is needed for us to do the condensate calculation, or where the condensate can be reused. So the authorities generally are specifying the minimum requirement for us to do the condensate calculation, or when we can, reutilize the condensate. So it's mentioned in the Dubai Building Code. So if your calculation is being missed, or if you have the tonnage which is achieving that particular load, then you need to do the condensate calculation. If you have missed, again, you will get a comment and then you need to redo the calculation and resubmit it. So these are some of the key aspects which we need to look in terms of HVAC. Similarly, you have the ventilation and fresh air calculations. So this is also something that again you need to ensure that you have the calculations are being done, and then you are showing them in the design as well as in terms of the riser diagram. So we are generally showing them in the design, but we are forgetting to add them in the riser diagram. So again, there will be a comment and he will be asking you to make a riser diagram and show him how the fresh air calculation is distributed. So these are some of the mandatory requirements what we need to look at when we are doing the HVAC design calculations as MEP design engineers. Some of the other important authority watch points, what the authority is generally looking on the projects. If you take the example of a warehouse, and when you have a very large warehouse, some of the time what we do is we miss out zoning, smoke zoning. So this is something which you will get a comment from Civil Defense Authority, even though the work is related to HVAC. But when you are submitting the drawings to Civil Defense Authority, you might get comments when there is no proper zoning being done. So you need to ensure with the architectural team that proper zoning is done, and proper, the areas which are defined by the authority are properly kept. Because when you have a very large warehouse, there comes a requirement of smoke curtain, and then you need to have a proper designated zone for extract as well as makeup. So these are some of the watch points we need to be very careful depending on the type of project we are working on. The second thing is related to fresh air and exhaust balancing. So generally when we are doing the design, what we see in the fresh air and exhaust balancing is that the design calculations are correct, but when we see on the drawing, the flats or the apartments are generally negatively pressurized, because the fresh air has been, calculated at a lower level, or either your exhaust is more. So the flat itself, individual apartments or flats are generally negatively pressurized. So this is something also you need to be very careful. Whatever calculations are being shown, ensure that the same things are shown on the drawing, and ensure that it is complying with the code. Generally, as we see on the Dubai Building Code, it's mentioned that your flats and apartments generally need to be positively pressurized, and the overall building also needs to be positively pressurized. This can only be achieved when you have your individual apartments positively pressurized. So this is something also again what you need to look for in the HVAC design. Moving forward, again, the pressurization logic and clarity of sequence, which should be clarified in terms of stairwells, lobbies, refuge areas. Generally, when you are having a fire situation or a fire scenario, so you need to ensure how the pressure logic, how the logic is going to happen in terms of, fire strategy. So this is also something which they are asking now for super high-rise buildings and super high-rise projects, high-rise and super high-rise buildings. So this is also something where you need to ensure that this logic is being presented. Generally, they are going to check on your design on the schematic diagram whether do you have a relief valve for the staircase. In case the pressure becomes too much, are you maintaining the 50 pascal pressure difference with the relief valve? So generally, the authority is looking specifically for this particular point on your riser diagrams. Again, you have N+1 redundancy expectations. This is generally for healthcare facilities. So there is another authority called as Dubai Healthcare Authority. So whatever we prepare in terms of design for healthcare facilities, generally it goes to the healthcare authority, and then it is being reviewed by them. So let's take example of an operation room. So generally there we need to have a redundant system, which is N+1. So we need to ensure that these things are clearly defined on the drawing. If it is not defined, again, it goes back and forth. There is loss of time in getting the approval. So some certain basic important aspects of design, we need to ensure that they are shown on the drawing, and the person who is going to review is, able to understand the intent of the design and what exactly we are trying to present him in terms of compliance of the authority requirements. I just wanted to put a few specific, images on this particular slide to show you the different things what you need to be submitting to the authorities related to the Dubai Building Code. If you just type on Google Dubai Building Code requirements or U value calculation, you get the tables and the calculations which are already provided by the authority. You just need to download and fill in the information specific to your project. So if you see here, we have the Dubai Building Code U value calculation, you have the glazing schedule, AC unit schedule. Similarly, for insulation, we have for villas type 1, type 2, type 3, type 5, type 6. Already the elements and the structures are already defined. We just need to input the values for the insulation sections for the villas. Similarly, the solar power calculator is also provided. So these are some of the things which are already the authority has uploaded and it's already available. We as engineers, we should be adaptable to the new changes and the standards which the authority is proposing, and ensure that we are submitting all these documents to the authorities. So you can just type on Google Dubai Building Code U value calculation, and you get all the Excels and all the insulation sections and everything which are readily available. And you fill in this information based on your project and ensure that these are submitted to the authorities when you're submitting. And also generally this is done by the consultants. Another important thing related to submission related to tarakhis which I wanted to mention was, as per the Dubai Municipality Circular number 77 dated in 2001, there is a specific checklist which has already been provided by authorities. It has a list of all the different things what we as MEP design engineers need to check before we are submitting the project to the authority. So the checklist is already provided by the Building and Regulations Design MEP Guide. This is mainly followed by Tarakhis, but it can be a generic checklist which you can prepare and then you can utilize for any submission. It can be related to DDA, it can be related to Tarakhis or Dubai Municipality, or the same checklist can be utilized for projects which we are submitting here in any other Emirates. It can be Sharjah or Northern Emirates. A quick case study on some of the projects where there was a rejection when the project was submitted. Uh, I already gave you this example where the fresh air calculations which were mentioned on the calculation sheet, because generally when we are submitting to the authority, we need to submit the complete calculation sheet along with the drawing indicating the same ventilation rates for exhaust and fresh air. So for a mixed use tower, it was not, matching. The calculated calculations are not matching the flow rates which are mentioned on the drawing. So this was the reason of rejection for the project. Just you get one single comment and it is rejected. And again, it goes into the process of approval and the authority takes certain amount of time. Once you have to correct all the required comments, what they are sending in, fill in the correct information. Again, you need to resubmit. Again, it takes 3 to 4 days of time for them to review. So the lesson learned from this is that we need to ensure that we are, double checking the information which is there. Another important thing for the reason for rejection for HVAC fresh air calculation is when your riser diagram is not matching your drawings, floor plans. And then there is a discrepancy between the drawings, the floor plans, and also your calculation. So ensure that all three are aligned, and all three should be like, for example, if you are showing on the drawing, let us say 350 liter per second, you need to ensure that the same thing is being shown on your riser diagram as well as the calculation. If it is 350.50, ensure that that 0.50 is mentioned on your riser diagram as well as on the calculation. Even if you have an extra point like 0.500 or 0.501, again, because of this, decimal point of 001, again, he can reject the file. This has happened even for HVAC as well as for electrical projects. So try to ensure that always you are using round figure numbers so that it's easy for the authority to review and give you the approvals. So this was related to HVAC. Moving forward, we will go and have a brief idea about electrical. So again, here we have the electrical authority requirements for all the different jurisdiction local authorities. So generally, the main, the framework is from IEC and the BS standards, which are generally utilized for the electrical requirements. We have DIVA requirements as well as DIVA for Abu Dhabi, and here we have SIVA and FIVA, which is Etihad V. All the three have their own different requirements, not major, but yes, each has its own way of submission, and each one has its own way of approval. So the process is slightly different. Later on the slides, we'll go through one or two examples related to the the electrical submission as well. But overall, the framework comes from International Electrical Code and the BS standards. And the other thing, what we need to ensure we are complying in terms of the electrical requirements are related to the emergency power for life safety, and also ensure that lightning and earthing systems are included in the design. I will take you through this in the next few slides. So some of the key important watch points when you're preparing the design as an MEP engineer, either an electrical engineer, is what is the location of your project? Whether the project is in Dubai, whether the project is in Sharjah, or your project is in Northern Emirates or Abu Dhabi, because the load schedule, what you submit to the authority is different. So when you are generally submitting the load schedule for Dubai, it's slightly different from what we are submitting for Sharjah. So ensure that you are using the same type of load schedules which the authority has already specified. So it's easier for them to review. Apart from this, also the load requirements. So generally when we are using the lighting loads, there is a slight difference of lighting load when we submit to DIVA, SIVA and FIVA. DIVA and SIVA almost might have the same lighting load requirements where we are using LED lights. But whereas when we are submitting to FIVA, they ask us to start with a minimum lighting load of 50 watts, and then 50, 100 and 75, 50, 75, 100. Whereas in SIVA, we can go on lower lighting loads. So this is also something which you need to be very careful about before you start the project. Ensure that what is the authority of jurisdiction on which the submission will be done. Generally, this confusion happens in the projects which are related to Sharjah and Northern Emirates. So before you start the design, ensure that the submission will be for which particular or which specific authority. Another important thing what you need to look for is the load letters and calculations. Again, as I previously told, ensure that the load schedules are matching to your local jurisdiction authority requirements. Number two, ensure that the loads are properly indicated on the single. One of the reasons for rejection is that if the units are not same. So when we submit for Sharjah, it is in kVA. So you need to ensure that the same is being shown on your drawing so that it's easy for the reviewer. And when you're submitting for Dubai, it is in kilowatt. So you need to ensure that you're submitting the proper loads on the single line diagram as well as on the calculation and authority forms. One of the important aspect in electrical, what you need to also look for is the room dimensions. So initially, when we are doing the initial design, we estimate the load for a project. So let's take again, go back to our example of G plus 50. So since we have a G plus 50 building, we need to ensure that we have, specific space allocated for the substation or the transformer room if you're in Dubai. So you need to estimate the load which would be needed for a G plus 50 tower and ensure you have sufficient space. Not only transformers, there will be an even HV room because it is a very high rise. The load requirement is very high and it is a super high rise building. So you will have your own substation, then you have your HV room, and then you have your LV room. This is only for the ground floor. Similarly, when you go on the typical floor, let us assume per floor you are having around 25 apartments. So also you need to ensure sufficient spaces are provided for the electrical rooms. Again, the most important thing is follow the minimum requirement for the electrical rooms. So if you have a submain DB, there are minimum requirements what the authority specifies. So you have 60 centi for the submain DB, then you need to keep a clearance of 120 mm for the door to open. So ensure that these clearances are met. And also apart from the submain DB, you will have your individual meters. So these are some of the points which we as engineers, need to ensure that are coordinated at the initial stage. not at the later stage of the design after the design is standard out, and later on we face issues on site. Also, if there are 25 flats, what we need to think is whether you are able to accommodate all of this in a single electrical room, or you can divide it into two different electrical rooms at two different locations. So as engineers, we need to, properly strategize and think at the initial stage itself how we can, improve the design, and also how best we can comply with the authority requirements. Another important point for electrical design is to have proper segregation of emergency powers. So again, here you see the interrelationship between different standards. So you have electrical requirements as well as civil defense requirements. Civil defense specifies that staircase pressurization, then you have corridor pressurization, smoke fans, extract fans, all these need to be on emergency power. So as electrical engineers, you need to ensure that all these requirements which are specified by the other authority are integrated in your design. So you need to collaborate and work together with the HVAC design engineer and ensure that the essential powers are there and you are integrating them into your design. In some of the projects where the authority has reviewed, they have commented that essential loads have been missed out, or either by mistake the engineer has put we need to look initially during the design submission. Moving forward again, I just wanted to show you the checklist which is already provided by, it's already provided by Dubai, Diva Electrical and Water Authority. So there is a specific checklist which is provided. Ensure that before, the drawings are submitted, the checklist has been properly reviewed. Each and every item on the checklist item has been verified on the design. So one of the example is the first one, if you see that there should not be any wet area, toilet, bathroom, kitchen, pantry, or a swimming pool above any electrical room. So this is something which we generally overlook or miss out in the initial design stage, because the architect is designing, he designs the electrical room, and above that he's designing a bathroom because there is a typical floor and he has apartments. So as electrical engineer, we need to ensure that we are reviewing the drawing at the initial stage itself with the architect, and we need to make sure that we are complying with the minimum requirements of the code. So the checklist is already available on the Diva portal and also on the Diva website. Also, you can type it on Google. You will get the complete checklist, which you need to ensure that before submitting you are complying. These are some of the different standards again for electrical. So you have the electrical standards for electrical installation regulation for Diva. For SIVA, you have SIVA wiring regulation. Again, for Abu Dhabi, you have the electrical wiring regulation, and also for FIVA. For Dubai, also you can use Dubai Building Code. All the information now for Dubai has been, condensed into a single book. So all the information related to electrical can also be found on the Dubai Building Code. Another important point actually which I wanted to highlight was related to the electrical loads which are being generally mentioned for, core and shell. Generally, when you are having core and shell, the engineers are assuming loads which are very less because they don't want, the electrical load to be very high at the initial design stage. But later on, when the design has been approved and moves on to the construction stage, there is a lot of, the contractors are facing challenge in terms of having proper loads for the core and shell area. So for we recently there was a project which was designed. It was completely for retail outlets. So there were around 7 different retail outlets like McDonald's, then you have KFC, different outlets were there. But the power requirement for each outlet was assumed to be only like 10 kilowatts, 15 kilowatts, or 12 kilowatts, 7 kilowatts, which is very, insufficient for these type of outlets to work on. So then it had to go back into a reapproval process, ensure that the proper loads are met, and then again they had to, reapply for the electrical load. So these things can be avoided initially when you have proper clear information. Ensure that you're discussing with the clients and also with the architects to give you proper information in the beginning itself to have a proper, electrical load estimation. Not only that, along with the electrical load estimation, your cable size is also playing an important role, because maybe the architect will tell you, I don't know at the initial stage who is going to rent out the outlet. So we as engineers, we need to keep certain amount of redundancy. So what we can do is we can ensure that there is an additional load which is there available at the sub-main DB, And then from there, whenever the load is needed, it can be pulled on with an additional cable, or we increase the cable size from the beginning, assuming that there may be an additional load requirement for that particular area of outlets. So these are some of the important things, as electrical engineers, we need to ensure that we are taking care at the initial design stage itself. Another case study related to electrical design was, initially there was a design which was submitted, and the electrical load was around, I think, 800 or 1000, 800 kilowatts. And later on, the project had been tendered out. The contractor, without being aware that the 800 kilowatt is the approved load, he completed his whole design. And when he saw that it is an 18% increase from the actual load which has been approved. So these are some of the things, even as a contractor, we need to ensure we are looking at what has been approved by the consultant, whether we are able to meet within the minimum requirement of minimum load requirement which has already been specified and which has already been approved. Because in certain emirates, it's a really big challenge to go and get reapproval for additional electrical loads. So we need to ensure that we are following the initial design. Yes, there might be certain discrepancies in the initial design. So in that case, again, you need to highlight these issues and ensure that we are going to try and resolve and comply with the minimum loads whatever we have. So again, here, one of the important lesson learned is we need to ensure that we are following the local authority requirements, ensure that you are reviewing all the documentation which has been provided either by the consultant at the initial stage, that is related to the authority NOCs, and also try to comply with those requirements which are already initially approved. Moving forward again to the next, building service related to civil defense. Again, civil defense for the UAE Fire Code is the framework for the entire UAE. But however, now different emirates are coming up with the local requirements specific to their local needs. So Sharjah recently came up with a different way and a different approach of how the codes are being reviewed and how the LSR needs to be prepared. It's slightly different from how you are going to follow in Dubai. So try to be aware of the upgrades in the codes which are happening related to your local emirates, and try to follow them to avoid rejections. And again, a UA fire code is formed from the parent codes which are coming on from NFPA. So we have NFPA 13 for sprinkler system, NFPA 20 for pump standards, 92 for smoke control, and we have many other NFPA standards which are all integrated into one code for us, which is the UA Fire and Life Safety Code. Uh, Moving forward, we'll be again looking at 2-3 different aspects related to the UA fire code. Some of the minimum requirements and compliances. If you open the UA fire code, it clearly mentions what are the minimum things which you need to show on the design drawings. So if you open the fire code at the end, uh, you will be able to identify what exactly is the authority looking for in your drawing. And we as engineers, we need to ensure that this minimum information is being shown on our drawings, not only to get authority approval, to ensure that later on at the next stage of design, the contractor or anyone who is going to work on the project will be much more aware of what exactly we are going to show on the design. Again, some of the important aspects which you need to look out for in the fire and life safety design is the LSR, life safety drawings. Ensure that you are working with the architects and complying with the minimum requirements of travel distances, dead end distances, common path. Ensure that the proper redundancy is mentioned in terms of the pump. Again, if you're going to go with a super high rise building, you will have your diesel pump, electrical pump, jockey pump. In certain projects where where you have 50 GPM pump, then they are generally going with electrical pump and diesel pump. So depending on the building classification and the type of project what you're going to work on, the redundancy and the type of pumps and the flow which needs to be identified need to be clearly identified from the codes. Along with this, again, you have the building classification and the occupancy type. So it's generally, we are talking about the hazard. It can be light hazard, ordinary hazard, a lot of different, depending on the application, you have different hazards. So we need to identify these things at the initial stage itself, because this is going to define the basis for our entire fire strategy for design. And again, you have the staircase with an occupant load. Generally, What I have seen is generally if they are assuming that a building is G plus 15, then they need to make the staircase width to be minimum 1.2 meter. If it is G plus 27, which goes into a high rise building, then we move it to 1.4. But that is not actual way of design. It actually depends on the occupant load, which needs to be calculated. So this is being implemented now in Sharjah. So generally, all the consultants need to do the occupant load calculation. Based on the occupant load, you decide the width of the staircase. So this is something what now the authority is also coming up with. So you need to know how will you be doing the load calculations for occupants and estimate the width of the staircase. Again, there are LPG requirements for Dubai. So there are minimum requirements for the tank and the different equipments which are placed on the roof. In one of the recent project, what I identified was they have so much of equipment on the roof that they are not able to comply with the LPG requirement of maintaining the minimum distance of 6 meters between any electrical or mechanical equipment. So at the initial stage, the drawing has been approved because initially there is no much of coordination, at the consultant level. But however, later on when the project is tendered out and the contractor is awarded the project, he's stuck with this problem now that he is not able to, manage the coordination on the roof for the LPG tank. This is one of the reasons. Again, you have the second thing related to the LPG tank. You need to ensure that the staircase has a direct access. So you cannot place an LPG tank on the top roof where you don't have, access from the direct access from the staircase. So again, this is also something which you need to be looking for in the initial design stage, because generally in the current situation now, when we see on the roof floor, you have a lot of swimming pools and infinity pools which are coming, which limits us as a MEP engineer to have our equipment on the roof. Ultimately, for us as engineers, we need to ensure that we are complying with the authority requirement. So this is something which you need to keep in mind at the initial stage of design itself. And again, you need to ensure that you have smoke management for staircase pressurization, corridor, lift pressurization. If it is a G plus 50 building, again, there is a compliance of having a dedicated enclosure for the lifts. So this is also something which you need to look out for. And also you have a fireman lift lobby, which is also mandatory for a high-rise building. It's not mandatory for a low-rise or a mid-rise building. But when you go onto a high-rise building, authority tells that it's mandatory for you to have a fireman lift lobby. And again, there is pressurization which is needed. So we need to be aware of these things which are already mentioned in the code and ensure that these are being implemented at the design stage. Moving forward, again, fire alarm and emergency lighting. Uh, One of the general thing what the authority looks for is on the fire alarm and emergency lighting is your riser diagrams. Ensure that they are properly, clarified. Proper loops are mentioned. Generally, what we see is typical riser diagrams, copy pasted from previous projects. But now authority is very much stringent. They are looking at the number of loops and number of points which are there on the riser diagram. So this is also something which you need to be careful and look forward in your designs. Also, another thing related to the pump room and the breaching inlet. So now the authorities are requesting the pump room to be having a direct discharge, to ground floor level. If you are having a pump room in the basement, you need to have direct access to the staircase, and the firefighters, in case of an emergency, should be easily able to access the pump room. And also the breaching inlet should be, somewhere which is very much visible, because if you see some of the previous buildings or older buildings, the breaching inlet was not on the main entrance. It was somewhere, on the service corridors or somewhere behind the building, which was not accessible. So now it's very stringent, and they particularly look at this point, and they ensure that the breaching inlets are within, less than 15 meters from the road. So the fire truck can easily access and have the connection to the breaching inlet. So these are some of the watch points related to the firefighting systems, what we need to be careful about. Again, this is something which I wanted to share. So you can open the UAE Fire Life Safety Code, Annexure 2, page 1285. Why does your drawing get rejected? The authority has already defined it clearly. So ensure that you are complying with these things before you submit to the authority, so that your drawings are approved from the first time. So you have already all the information available from architectural drawings, life safety drawings, firefighting drawings, emergency, smoke, LPG. Everything has been mentioned by the authority. So try to create a checklist and ensure that these things are verified before the drawings are submitted to the authority. If any one of the items in this is missing, your drawing will be rejected. The authority has clearly defined it. So this is another example for a fire pump where the authority, during the initial design stage for a super high-rise building, the drawing which was submitted was just showing a single pump. It was not showing, a diesel pump. So it was just showing an electrical pump, and it was submitted, and the authority had rejected, telling that it is non-compliant related to NFPA 20. That is the standard for pump and for the classification of the building. So these are some of the things which can give you a direct rejection. Very simple thing. We know that in UAE it is not allowed to have only one single pump. But on some, when this happens generally when the design is being outsourced, when developers and clients are not aware of the local requirements and they try to outsource the project and give it to people who are not aware of the local codes and do the design, then they try to do the design based on their codes and their requirements, and then they submit. No one is reviewing here, and then it is submitted to the authority and it gets rejected. The whole project was delayed for more than 8 weeks just because then they missed to show the pump on the pump room. So this is also something which we need to create an awareness that all engineers need to be aware of the local codes and regulations. And outsourcing a project is not a solution. You need to ensure that even if it is outsourced, competent people are designing and reviewing it before it is submitting to the authority. Moving forward, we have last two building services which are related to plumbing and drainage. So we'll just try to move on a little bit faster and try to give you information related to water supply and drainage. So again, when we go on to plumbing, we have different requirements from DIVA. You have Sharjah Electrical and Water Authority, SEWA. We have requirements related to water supply, Abu Dhabi, and also for Etihad, FIBA. So there are different requirements again related to the different emirates and the different authority on jurisdiction of authority which we need to comply with. This is a quick table which I have taken out from different standards. The first one is from the Dubai water regulation. So it specifies the amount of water which you need to calculate. The second page is the sheet which you need to submit to DIVA to get the approval, which estimates the total water demand. The third one is related to the solar water heater calculation, which I already showed you in the Dubai building code. So generally, when you are doing projects, especially for villas, when you are going to submit the solar water heater, so this is the calculation which you need to submit along with the drawings. And the last page is related to the SEWA regulation. The regulations are very simple and are up to the point. In bullet points, they have mentioned, but still there is a lack of compliance related to the basic regulations which are being specified by the authority. And authorities have clearly defined what they need in the design. So as design engineers, we need to ensure that we are adapting to these requirements depending on the authority and ensure that these are being complied and are being submitted to the authorities in the way what they want, so that the projects are approved at a faster pace. So I just wanted to show you three different, images here. Just have a look at these three images which I'm showing, and maybe at the end during the Q&A, I will ask if anyone would be able to, answer which authority is specifying what type of water meter arrangement. So this is what I want to understand. So there are three images which are related to three different authorities. I just want you to maybe answer me at the end, just looking at the image, the requirement, and specify what is the authority which has specified this particular type of arrangement. We will have a look at it during the Q&A session for this particular specific slide. Moving forward, we have the plumbing codes hierarchy in UAE. So again, you have the local municipality regulations for plumbing code. which are related to, again, it is coming from the parent code, which is the IPC, International Plumbing Code. And then you have the British standards as well. And also from ASP, that is American Society of Plumbing Engineers. All the codes are integrated. And then you have the local regulations which are being formed. And also, especially in terms of, plumbing codes, there is also an interrelationship between fire life safety also, because there is a requirement of fire water demand. So we will see later on in the next slide the relationship between how these regulations are combined together and how we are going to estimate the water demand. But in general, this is how the hierarchy of the plumbing codes are there here in UAE. Some of the common reasons for rejection for drawings related to water supply in DIVA or in SIVA and also in FIVA, water demand calculations are being missed. Your overhead tank size is not complying with the regulation. So the authority tells that the overhead tank needs to be, half of the underground tank. It should not be more than the underground tank. In certain cases, you are designing the underground tank, let us say for 12,000 imperial gallons, and then you are showing two tanks up on the roof, and then they are more than 12,000. This is rejection from SIVA. So this is also something which you need to look for. Fire water tank integration. You are showing your underground water tank, and then you are just showing the domestic capacity. You are not showing the water capacity for the fire. So again, this is a reason for rejection for water supply drawings. Again, you have water meter room compliance. So similar to electrical, you need to ensure at the initial design stage itself that the minimum room for the water meters is being accounted for, and you have minimum space. Now in Dubai, they are very strict. If you are not going to comply with the minimum requirement of water meter room, uh, initially maybe at the design stage it is approved, but later on during the construction stage, when the DIVA engineer comes on, on site, or when you're going for the construction NOC, it's a very big challenge to get approval again for the water meter room. So especially the consultants, they need to ensure that these are being met at the initial stage itself. And also when you're submitting the water supply drawings, ensure that you're adding the structural tank details, because it is something related to the structural design. So we give the capacity of the tank to the structural engineer. He needs to ensure that the design has been done structurally, and it should be a part of your, drawing, because that is when you will know what is the total volume which you are getting and how much is the freeboard which is available. So this is something which we generally miss out. But in Sharjah, if you miss out, you don't get an approval. So you have to show your structural tank details in your water supply drawings. Maybe not in Dubai, but in Sharjah, it's mandatory, or else you get comment and then you need to resubmit the drawing. Similarly, moving forward, some of the mandatory requirements, again, utility provider water demand calculation. As I showed you the calculation, either it's mandatory for Dubai. In Sharjah, they are asking for a schedule now. So you need to prepare a water schedule and then you need to submit it. Though the format is different, but the intent is to show the water demand. Then tank size as per the authority. So DIVA, it specifies 24-hour storage for the underground tank. The overhead tank can be equal or it can be half of the underground tank. The same happens in SIVA as well, and all the other authorities. Ensure that you are showing your standby or the booster pumps on the roof, and also ensure that you are showing, backflow prevention valves or PRVs when you are having a super high-rise building. If we take our previous example of G+50, we need to ensure that you are showing proper pressure breakers as well as PRVs for the to avoid the pressure within the pipes. So these are some of the mandatory requirements which we need to, look out for when we are submitting the drawings to authority. Similarly, again, the water supply authority watch points, again, it is related to the tank, 24, 12 hours or 24 or 48 hours, your underground water tank, whatever you are going to estimate. Generally for healthcare facilities, we are estimating 2 to 3 days as the water storage for the underground water tank. So this is something you need to look out for depending on the type of project you are working. Again, as I already told, pressure zoning for the buildings. If it is a low rise, high rise, if it is a super high rise, then you need to have proper zoning, metering and accessibility, proper water meter rooms to be identified, and ensure that your pump are redundant. So you have duty and standby pumps both for transfer as well as the booster pumps. Again, here there is a case study, which I already told. When your water meter room is non-compliant, then it becomes a challenge. So insufficient dimensions were there. Then initially in the tender drawing, it was approved, The meter room was approved by the initial design stage, but later on during the construction NOC there is a challenge, and then the authority is telling them to make the modification. What happens is now, in case they modify the water meter room, he needs to make certain changes in the architectural design, which can impact structural design, it can impact the civil defense life safety, it can impact the other services which are there on the project. So designing from the beginning with proper compliance can save all of this hassle which can happen at the end. So so this is something what we as design engineers need to ensure that we are complying at the initial stage of design itself. Moving on to the last stage, which is the drainage. Again, here we have drainage requirements which are already specified by the authority, which is Dubai Municipality and Sharjah Municipality. And in FIBA, generally they are not reviewing drainage drawings, whereas in Dubai and Sharjah there are requirements for getting approval for drainage as well. Again, different jurisdiction authorities like DDA for free zone and Tarakis have their requirements and review for drainage drawings. So we need to ensure that we are complying with those. So some of the key requirements are: maintain the minimum slopes already defined by the authority and the requirements, venting requirements, first and the last manhole to be vented properly, proper traps are provided, manhole spacing, there are minimum requirements for the manhole, it cannot go more than that, and also the depth. If the depth of the manhole changes, the shape of the manhole changes. So you need to ensure that these things are being mentioned on the drawing. And another important thing is your house connection. The levels which are mentioned on the house connection need to be followed in the entire design. So these are some of the requirements what you need to follow in terms of the drainage drawings. Moving forward, some of the reasons why the projects are getting rejected when they are being submitted in Dubai: drainage flow calculations are missing. Also now in Sharjah, in certain projects, they are asking for flow calculations to be shown. You need to estimate the drainage calculations. Manhole invert levels, not following the invert levels which are there on the NOC from the DM or from SIVA. Your house connection level should be followed back, or at least you should indicate 00 level with the architecture and ensure that the manhole levels are followed properly. Underground clashes, as I previously told, if you are having a water line and then you have a soil line, then the minimum distance between them should be 1.5. If not, then you get a comment that you need to modify, or you need to reroute. The problem comes because your water supply would have already been approved by authority, either DIVA or SIVA, and now again you are going to have municipality submission, and then he identifies that these two lines are close to each other. So again, it goes back in a reapproval process. Municipality house connection levels, vent pipe requirements, as I told, first manhole, last manhole, ensuring that the vent pipes are at a particular height at the roof, complying with the regulation, and also adding pressure breakers in drainage for high-rise buildings. So these are some of the reasons why your projects might get rejected when you submit to the different authorities for plumbing systems. Again, moving forward, some of the key watch points which we generally miss in the design: grease trap sizing and location. So generally, when we are doing designs in, for Sharjah, it's mandatory to have a grease trap wherever you have a kitchen, and wherever you have a commercial, space or a commercial retail outlet. Again, you have restaurants which are coming up. So identifying this in the beginning is very important. If there is a space which is a retail outlet, you have different shops, and you don't know which of these shops are going to be a commercial outlet or a restaurant. So having the discussion with the client and telling them that at the initial stage itself, that there will be a requirement from authority if there is going to be a restaurant. So the grease trap can be initially incorporated in the initial design. So having a proper communication and ensuring that you're complying with this can save a lot of time again at the later stage. Again, vent termination heights. Generally, in the previous few years in Sharjah, we saw that the ventilation pipes for manholes for the first and the last manhole was just taken along the compound wall, and it was left. So because of that, the smell from the from the sewer used to start to go around the compound wall of the villa, which can be easily avoided if you are having a proper ventilation pipe which is going up to the roof. So again, as a design engineer, we need to look at these things. Generally, the easiest way is to just take a branch from the manhole, take the vent pipe and then just put it onto the compound wall, but it does not meet the design intent. Again, for some pit, generally what we see in buildings is ventilation is being missed, and also pressure pipe is not being shown, and pressure braking manholes are missing. So these are some of the things again which we need to look out for, mainly when you have some pits. And again, manhole levels and slope, already the authority has defined the invert levels. We need to ensure that we are following these minimum requirements related to the manhole levels and manhole slopes, and the same need to be shown on our design. A case study, again in in one of the project which was submitted, the design engineer has mentioned the levels properly. From his perspective, when he has designed, he has mentioned everything with the zero level and complying with the architectural levels. But when he submitted the drawing, the authority commented, and they sent back the drawing stating that he needs to revise the levels based on the DM levels, because for them the invert level for the house connection is based on the DM levels, and then they want to ensure that the invert level of the DM level or the house connection is matching with the FIC. So this is also something which you need to be very careful when you are submitting the drawings for Dubai municipality or DDA or Tarakhis. Ensure that your levels are the same when you are submitting the drawings, and complying with the NOC, drainage NOC or the sewerage NOC, whatever you receive. Similarly, in Sharjah, for the developed areas now, there is NOC which you will receive for sewerage. So ensure that you are complying the same cover levels as per the authority. Another important thing in one of the projects on which I had worked, it was again a park, a CU park 4 and 6. When we worked on the project, the invert level was going very high. It was going more than minus 1.2. So in that case, try to ensure and try to check if the invert level can be reduced, whether you can reroute it through a different way. If it is not possible, then in that case, you need to have, you need to have a sump pit and submersible pump which needs to be added. We added these details in our project. So the maximum invert level is minus 1.5, 1.2 in Sharjah. You cannot go below this in the invert level. So this is something what you can keep in mind when you're doing the design. We are at the end of the presentation. I had just created a quick executive checklist for all the engineers who are going to be designing and who will be, working as MEP engineers. Ensure that you are having the design criteria approved, following the proper minimum requirements which are being specified by the authority. Your calculations and drawings are matching and are aligned. Fire strategy and sequences are attached. Life safety reports. It can be any calculations. Try to ensure you give as much as supporting document to the any design what you are doing, and also ensure that the utility forms are complete. Generally what happens is these forms are being filled by the person who is just dealing with the authorities. It's not the engineer, but ensure that you review as an engineer the utility forms, or not the NOC coordinator who just fills in the form based on the information what you give. Just try to recheck all this information before you submit to the authorities. Just a quick takeaway. I hope I have shared a lot in a short period of time. That was the intent, to give as much as information as possible related to the different, building services and the different regulations and authorities. That was one of the intent with which we came up with this particular topic. UAE compliance, how you can get documentation done. Documentation is something which is very important and critical in any stage of the design. Early coordination saves time and cost. This is something what you need to keep in mind as design engineers, and ensure that at the initial stage itself you are trying to solve all the issues related to the design, and later on there are no challenges in terms of implementation of the project. That's it from my end. Now I'd like to open the floor for discussion. Thank you to everyone who have joined and stayed for so long. I hope I have shared sufficient information which you can take forward and then implement in your designs. Thank you.
Gentlemen, if you have any questions, you may please go ahead and put the questions forward directly to um, Engineer Murtaza. And if you don't have any questions, even you can ask the questions later on the WhatsApp group, or you can send us to an email as well. There is one good information what I'm going to share with you guys now. Is our platform is now going to launch a AI bot in our website. Very soon we are going to launch this AI bot, wherein we are it will facilitate to all the engineers to just post the question to the AI, and it will give us the response from the available data of the UAE MEP engineers website. We have a big data library, and you don't need to go and search for the library. Just put a question to the AI bot, and immediately you will get the answer. And the next stage will be we are trying to get the AI bot directly on the WhatsApp UAE WhatsApp MEP group. So it will take some time for getting that is to the WhatsApp group. But initially, in very few days, we will be launching the AI bot for our website. So this is what I wanted to announce to this group. And inshallah, we will have the next year coming 2026. We will be having a good amount of webinars as well. We will be sharing the calendar of the webinars. Whatever the attendees of the webinars, the important thing to note is you will be getting a certificate from our side for the certificate of the participation. So, any questions here? Please go ahead.
Good afternoon, Engineer Murtaza. I just want to know, can you tell us that existing regulations, which is not required anymore, but still we are following here in UAE, like the velocity breakers. Previously, it was shown in the drawing itself. Nowadays, there is no requirement for velocity breakers as a authority requirement.
Uh, Velocity breakers related to the plumbing system, right? Drainage.
Yes, yes.
Yeah, no, it's required now. If you are going to submit the drawings to SIVA, it's not mentioned anywhere in the regulation as such, but now authorities are reviewing it specifically. So when you are going to submit the drawings related to drainage, and when you are having a building which is a high-rise building, they are requesting to have pressure breakers for the system. It's not there mentioned, but when he's reviewing it, it will be commented by them. It's some of the things what I have shared with you are not like specifically mentioned in the code, but these are some of the comments which we have already received from authority on some of the ongoing projects. So those are some of the things which I have highlighted. One is that, and also if you check the water meter rooms in Diva, it's minimum 1.5 by 1.5 now. If it is anything less than that, they are not accepting again. So these are some of the comments which we have received.
Yeah, similarly in the case study, which I have to share that the water meter room size, we have one project, we submitted the drawing. We have a commented that the water meter room size to be maintained as per the minimum, but later on we have submitted due to the space constraints. We gave
Yes,
a undertaking letter that okay, this is the maximum we can give. So they accepted it in the conditional approval like that.
yes,
So and also
they are
yeah.
accepting it as a conditional approval, but again, they will highlight it to the consultant. Maybe if you are from a consulting background, they will send an email to the consultant that this has to be avoided and it cannot be happening again from the same consultant in the next design. There is only one, maybe the first design they are giving approval.
Okay, one more thing, Engineer Murtaza, regarding the PRMS main entry to the building. Uh, we
Yes,
have recently done one project. In that PRMS station and the breaching inlet, both are in the same location next to each other. Then I have did the study. Then I found that gas international codes asking us to maintain 2 meter distance between breaching inlet and the PRMS. Then I have provided my design and then I have kept 2 meter distance. While constructing the thing, there is no, we have some constraints, so we kept all both together. Then we submitted in the authority approval. We got approval. So I'm just wondering, it is the mandatory requirement to consider between 2 meter breaching inlet and LPG PRMS, or we can just ignore.
No, see, as per the code, it's mandatory. You need to comply it. Generally, certain aspects of the code, when they are being submitted to the authority, it's just like they are sometimes overlooked actually. Like, for example, I gave the example for the LPG tank on the roof. They are having two FAHUs and the LPG tank, it is not complying, but it is approved by the authority at the initial stage. But as design engineers, for us, in order to have this compliance, and the safety, it's again up to us. So that is how generally we are going to provide a proper implementation and a proper solution. As per the code, it is required, mandatory. But now on your site situation and constraint, you are not able to meet that. But at least you will try to ensure that if it is 2 meters minimum, you are 1.8 or something like that. That's how you are getting the approval from the authority. It's but as a regulation, it has to be met.
So you're saying that I have to get a approval for as built like that to the
Yes.
authority?
Yes.
Okay. One more, the last one, I have to few more questions. Considering the other times, I just want to go through. This is the last. The requirement of pressurization fans for the lift. You said G plus 15.
Yeah.
So I have a doubt here because in our project, one project we have, it is G plus 40, podiums and 25. So we don't have a pressurization fan here in this case. But the corridor, the authority, when I approached them, they said if the corridor is isolated from the, sorry, the lift lobby is isolated from the corridor, like a smoke, in terms of smoke, you don't require the lift pressurization fan. I'm confused here because when there is a fire, the lift lobby doors should be open
Yes.
towards the exit. But in our project, we don't have access control also. It is open corridor to the lift lobby. So in this case, I'm just confused. It is
No.
required to provide.
Yes, yes, I understood your question. It's clearly defined in the code. If you open the UAE Fire Life Safety Code, when you go to the smoke management, chapter 7, chapter 10, and then when you go down at the last stage for applications of smoke management system, there will be, two topics. One is related to high-rise building and another one is related to super high-rise building. Under that, there are two conditions. Condition one states lift pressurization is required if you don't have when the corridor is an open corridor, when you don't have zoning or any partition related to the other zone, when it's an open corridor, then you need lift pressurization. But when you are having, when you are dedicating this as a separate zone, in that case it is not mandatory. That is what the even the civil defense authority has commented for you. I hope I clarified the question.
Yeah, yeah. Engineer, the last one you said the minimum condensation calculation.
Yes.
I think it is 300 kilowatt, right? Or 300 to 350, something like that.
Yeah, it's for 350 kilowatt. If your building is having an the air conditioning load of more than 350 kilowatt, then you need to have mandatory condensate recovery done
So
in
like a
your house.
tank, we have to collect that one, then we have to utilize that.
Correct. You need to have a condensate tank and then you need to utilize this for drip irrigation.
Okay, engineer. Engineer, if you have time, can I ask one more question?
Yes, please.
Engineer, regarding the staircase pressurization, I have to give some example. I have a pump room in the basement for the fire pump. I
Yeah.
have taking backup air from the ground floor and then exhaust also I'm throwing out from basement to ground floor. So due to the space constraint, I'm just running the makeup air duct through the lift lobby. Then I submitted the drawing. The authority is asking me to provide dedicated 2 hour enclosure for the duct around. So I have updated the drawing. I have submitted it. But later on, in the podiums, the contractor doesn't have the space to run the staircase pressurization duct. They are forced to run through the podium lift lobby. I'm afraid that still the ceiling is closed now. When the authority inspection come, is that requirement to get the mandatory of 2 hour fire rated enclosure for the duct, or it is no need for the staircase pressurization?
Uh, Actually, I For this, you told that you're having a pump room which is in the basement, and then you're having your makeup air duct which is crossing over the lobby.
Yeah, yeah. But initially I submitted without the enclosure of 2 hour. Then I got the command to provide
Yes.
2 hour
Two
fire
hour
rated
and
enclosure.
yes.
So I have provided it and got approval. Then later on during the construction stage, in the podiums, not in the ground floor or in the basement, the contractor, when they are rerouting the staircase pressurization, they are running the duct through the lift lobby. I am just afraid the similar case here also. They required the enclosure for this duct also or not required because it is the staircase pressurization only.
Staircase pressurization is passing through the lift lobbies.
Yes, yes,
It's passing inside the ceiling.
yes,
Already it is fire rated duct 2 hours.
yes.
So it is not required.
So in this case, why they asking us to provide in the makeup pair in the ground floor?
In the ground floor, where is it passing?
In lift lobby.
It is passing again in the ceiling.
Yes.
Because it's already a 2 hour fire rated duct, which as per the code, you need to have 2 hour fire rated duct, which needs to be given for the staircase pressurization.
Yeah. Both ducts
It
are more fire rated. I'm compliant for the material wise.
yes,
But in the ground floor, I'm running the makeup air duct through the lift lobby. They are commented like this. Then later on
makeup.
stage, during construction, here again happened in podium. Same situation, but the application is different. It is a staircase precision duct. It is
Yeah,
required to have an enclosure or not required? That is my question. Or should we resubmit the drawing to the authority like as built or something like that?
it should not be required actually if a staircase pressurization duct is passing through. Because generally, when we have smoke extraction ducts also are passing through our lift lobby, right? It is the same case.
Yeah.
You have makeup air ducts and staircase, the corridor smoke management system ducts are also passing in the ceiling. That is also fire rated system.
But they are quoting that it is a smoke control system. You should have the dedicated shaft requirement, the complaints to the code. They are quoting that one. That's why I'm having confusion.
Dedicated shaft in the sense maybe he's trying to tell you that you need to have a direct shaft to the staircase,
Mm-hmm. Okay.
direct dedicated shaft along the staircase.
Okay, engineer.
Because if you open the code, this example is mentioned in the code that for
Okay,
the
okay.
staircase you have a direct 2 hour fire rated enclosure and the duct is going inside this enclosure. The example is there, so maybe that is the reference what they are giving to you.
Okay, engineer. Okay, engineer. Thank you so much, engineer.
No problem, thank you.
There is a question from Abdul. Can you please raise your concern, Abdul?
Yeah. Thank you, Mr. Murtaza, for your session. It was very informative. Okay, just have a question regarding this ERVs. So, is it a mandatory requirement of this ERVs for Dubai? This
Mandatory.
energy recovery ventilators,
No,
for
no,
the
no. It's mandatory. ERVs are mandatory only when your fresher load goes more than 1,000 liters per second. When you're even if it is a villa or if it is a very a large mansion, if your ventilation loads goes more than 1,000 liters per second, then ERVs become mandatory for you.
no matter if it's a villa or a building.
No, no, no. If your fresh air calculation exceeds 1,000, because when you open the AC schedule, which I shared with you from Dubai Building Code, you need to input the fresh air requirement there. So as soon as your fresh air requirement goes more than 1,000 liters per second, you will get a red box indicating that heat recovery is mandatory.
Mhm.
Then the authority will check that particular requirement and then they will ask you to submit another schedule which will show what type of heat recovery you are going to use and you need to give a schematic for that.
Okay, it can be an FHU or ERV. I mean, I think it's
Yes, for the FAHU. Yeah.
FHU. Okay, and okay. Secondly, this one now earlier we used to get the schedules from the heat load schedule, and it used to be mentioned for the FAHU the air inlet as 4630, but now we see the trend coming to 3432. So what's the historical background and for this? Could you please shed some light on that?
Yes, for sure. Actually, there is, it should be 3432. The reason why 3432 is coming is, why are we using an FAHU? First of all, we need to define that. The reason for the FAHU is in order to reduce and control humidity within the space. So for us, especially here in UAE, our relative humidity is very, very high. The humidity at 3432 goes to the maximum. This is the extreme humid, like the conditions which are there for 3432. So when you go for 40, the previous, it was 46.
Yeah.
When it was being designed at 46 degrees, the entire humidity which was there was comparatively less than 34, 32. The reason for FAHU is and to ensure that we have proper dehumidification happening within the space. So that's why now it's clearly defined that we need to go with 34, 32. This is the temperature at which we have maximum humidity
But
and maximum humid condition.
yeah, I got it. But it's very. I believe it's only for a very limited period of a year. It can go to. I mean,
Yes,
uh,
you are right. It is not throughout the year. It goes to it happens only at one particular or a specific number of days in a year. But still, our FAHU is designed at already the extreme humid condition. If you are going to design your FAHU at 46, the cooling load which you are calculating at the initial stage is huge. From 46 to 34, maybe I can save, let us say, around 100 tons difference might come, which I don't need my equipment to be oversized, because already I am supplying. My FAHU is mainly used just to have outdoor air and proper dehumidified outdoor air within the space, and I'm supplying it at 24 degrees because I have my own dedicated cooling system within the space. So it's not like cooling. We are not going to cool the space with this load from the FAHU. It's just to have proper ventilation and proper fresh air within the space and proper dehumidification.
so you mean to say that if the unit was designed at 4630, it would have been a bigger unit and compared to a 3432?
Uh, the loads, the tonnage at the tonnage at 34, 32 might be higher, but the other loads related to sensible and the other loads will vary. And again, the overall load for the system for the FHU at 34, 32 is high, not at 46. But for us, the main intention for the FAHU is mainly for dehumidification and for to have it designed for extreme humid conditions. That's the reason why 34, 32 is being adopted.
Okay. As per your experience, what period do you think is we have this 34, 32? I mean, that's higher on the peak period, maybe 2 weeks, and during which months usually?
Yeah, for this specific, so for this actually, if we open the ASHRAE, I cannot remember the exact number of days, but however, there is a reference for this actually. If you open the ASHRAE weather data on Google, if you just type in ASHRAE weather data, and there you will get the exact number of days which 34, 32 is being coming up throughout a year, and also 46 temperature at which we are designing our outdoor conditions. For our air conditioning system, the number of days it's happening in a year is clearly defined in the weather data for ASHRAE.
So you think it's around 2 weeks or something like that?
I think so. It should be with, like less than 15 days.
Okay. Okay. So and
Before we close our session, we have two more questions here, Murtaza, because we are running out of the time here.
Yes.
Parties can send their questions later on the WhatsApp group. We have one question from Mr. Sarang Kelkar, who has put a message: do we need separate room for chill water BTU meters? The answer is yes, we need to have a separate chill water meter room, because this is any BTU meter, it is installed for district cooling systems, and it is an authority requirement. Secondly, Mohammad Kaleem, our very old colleague, he has requested to put some light on the Tarakhis cards and yellow card and green card, etc. So we will be providing this information through the WhatsApp chat and by the email. it can be available, because since we are running out of time, I don't want to have very lengthy detail on it. Murtaza, is it possible, can you give us a brief on this yellow cards or anything? Just a quick brief.
Yes. So in order to, get the drawings approved from Tarakis, and also in order to have the project maintenance, the engineer who is going to be on the site for site supervision for the project, he needs to get these particular cards. So if you just go on to the Tarakis website, so there is a particular fees which needs to be paid. I think it's approximately 3,000 dirhams. And then the engineer needs to prepare the guideline which I showed, the Tarakis book for MEP design. He needs to go through it, and then he needs to go and clear an exam, which is an online exam. So once he clears the exam, then he gets the card as a Tarakis approved engineer, yellow card and the orange card.
Okay, we have Sikandar who has raised the hand for question, and after that Muhammad Mohsin, and we will close the session after that. Sikandar, go ahead.
First, yeah, first of all, sorry, anyone is continuing? Can I continue?
Yeah, please.
First of all, a sincere thanks to Sayed Saab, UAE MEP Engineer Group, and Mr. Murtaza Saab for arranging this very detailed this one. And second thing, regarding the FAHU, regarding the heat recovery, when you was explaining, just I got one small doubt in that. Instead of going with FAHU, can we go with just energy recovery? Since we have already air handling unit for cooling, for feeding the catering the load requirements. Instead of feeding again, going with complete FAHU setup, above 1,000 liter per second. So energy recovery ventilator shall suffice, right?
Y- y- But again, you need to bring it down to a particular temperature. So there will be a certain amount of load which will be there. So that with just an ERV, you might not be able to achieve the minimum, like the load which we want to supply. It's around 24 degrees if you are going to supply from the FHU. So you might not be able to achieve that directly only with an ERV, just by recovery of heat. And plus also dehumidification should happen.
So that duty, that dehumidification, the dehumidifier, like with placing of electrical heater in the AHU side, since already the load, the cooling load can be achieved through AHU. Since the volume of air pressure, like we have an auditorium where the pressure load required is huge. So of course, there should be air extraction from the auditorium. So this can be done through ERV. This was my just concern, since AHU is already catering the cooling load for that.
To make it the answer very simple, Sikandar, this if you are having a huge pressure load, ERVs generally cannot be possible to give you this kind of temperature, bringing down of the temperature. FAHU, having a FAHU is become mandatory at that time, because your purpose is to bring down the temperature as well. ERV alone cannot do the work.
And thank you so much. Shukran.
Okay, Mohammed Musin, last question, please.
No,
Yeah, it was me, Mohammed Hussain only. I got clarified. Thank you so much.
the
Ah,
Sikandar is here. I didn't ask Mohammed Mohsin. He asked the question.
okay, Sikandar, tell me.
Yeah. The regarding the fire pump room, we used to have bandwal for the diesel tank. The
Yeah.
requirement of the bandwal is 150% of the capacity. But some of the consultant is saying put sand inside the bandwal. Some of them it's not required to put sand inside the bandwal. What is authority requirement on this? And also, if any one more question, this is my last question. If the building got fire, if there is some minor fire or whatever it is, we can use the same fire pumps again for the same building, or we have to replace it.
As long as it is working condition, yes, you can use it. If it is not in the working condition, then you cannot use it.